at various places so far, but always exciting to share again. So, some background, this was a historic retrofit that was completed in 2022. And it's Pepper Construction's office building in Cincinnati. And it achieved historic tax credits as well as LEED Gold, Well Gold, and LEED Zero Energy certifications. So, with that, I'll go into our project team and let everybody introduce themselves.
Hey, my name is Tony Budke. Currently, I oversee our pre-construction here for Pepper. At that time that we were building the project, I was fortunate enough to work with Brett and the design team and oversee the construction of the office. So thanks for having us today. And I do apologize, I'm on a job site today, so if you hear some stuff in the background, I'm going to keep muting.
And then I am Allison Bernacki. I am on our high performance and sustainable construction team with Pepper Construction, and I've supported the various certifications and the LCA study on this project.
And I'm Julie Cromwell, President and CEO of Julie Cromwell and Associates. We were the structural engineer of record for the project and honored to be a part of this team and this project.
Hi, everybody. I'm Wyatt Ross. I'm a building performance engineer. I was with CMTA, who was the MEP engineering consultant on the project.
Hi, everybody. I'm Brett Mocht, principal here with Emersion Design, and was very fortunate to be the architect for this project. So I'm excited to share.
Awesome. So we'll quickly go through some learning objectives for the presentation. So we'll go through why Pepper chose the project and the location, some of the structural requirements and repairs that were necessary for maintaining parts of the existing building, the integrative process and project team that was required to achieve all of these sustainability and historic tax credits goals. And then finally, how our project team used the whole building life cycle analysis assessment and was able to track the embodied carbon of the project. So first, we'll start with Tony going through some of the existing conditions of the building.
Yeah, great. About 4 to 5 years ago, we were in a really small leased office space. We were growing pretty rapidly and needed a new home. And we wanted something that Pepper owned to really throw a flag in the ground here in Cincinnati. We were looking at renovations, lease spaces, my boss, Jerry Noble, is really into historic buildings. And we stumbled across 100 Williams, where we ended up going. The building had good bones. It was a part of a historic district, which let us, apply for those funds to help make the project possible. But I got to be honest, the first time I walked in that building, I thought he was crazy. And we'll show you some of those photos here. As we went through selection for design teams, it was pretty easy for us to make that selection on the RFP with CMTA and Immersion, with their sustainability and our relationship with JCA and what we knew they could do. So go ahead and flip for me, Allison. So that's our building. Allison, I don't know if you can scroll over it. There you go. That's a closer look at what we got. We knew sustainability was going to be one of the top goals for us. And it was really interesting as we went through some of these design parts and pieces and what was important, whether it was going to be LEED or net zero or just overall sustainability. And those were calls that were made at the very top of the company with Stan Pepper and leadership at that level to really put our money where our mouth is. And if we're gonna stand for something, then let's show them what we can do. As we went through the LEED process, we didn't start with do you want to be lead or do you want to be well certified? We laid out our goals, and that was driven by the immersion team. And then we're able to back into our different certifications that we're able to get, and then put some of those stretch goals down on paper. Um, as you can see, Allison has up here what the building looked like when we got it. It was a little scary. That's a vault there to the left. And that floor right there ended up being one of the areas that was caving in. By the end of the demolition project, the job site looked like a I don't know, a movie set. I mean, there were planks walking all over the place, just trying to figure out how to walk in and out of it. But it was really neat to see it get taken apart and put back together. Go ahead and flip, Allison. So we brought on Beth Sullenbarger. I think she was actually walking in the background in one of those photos earlier. Beth really helped guide us through this process, really to get the tax funds that were there. She was an expert. She actually was a part of getting the community of Lockland to be a historic district. So it was a really big proponent. It was interesting working with the state of Ohio and the federal tax credits that come along with it. The state of Ohio has some of the highest standards across the country. So after they stamp it, it basically just goes to Washington and the federal government basically for a rubber stamp. And I feel like the design team and Beth really nailed what we needed to get through on that. So some of the historic elements that you can see here that really just, day to day are just beautiful reminders for us. Over on the right, the fireplace is one of our main features in the building, and just beyond that, in that photo, is our boardroom. Fortunately or unfortunately, we're not burning logs in that fireplace anymore. And the beautiful doors on the left were not original to the building, so we ended up replacing those with a more modern glass door and rerouted our entrance to the other side. I mentioned it looking like a movie set a little bit earlier. As you can see, we had extensive demolition. Julie's team came up with a good plan on how to put it back together. We worked on how to construct it ground up. But this portion of the building, we had to gut from the roof all the way down. We took the concrete floors out, put new concrete floors in there. So it was quite a feat to just keep it standing while we were tearing that section of the building apart. But then wedge all the new floor beams into it and bring a modern structure to the building. One of the interesting things, Brett, feel free to jump in here whenever you want. But working with the Historic Society and what we were allowed to do and not allowed to do, this front elevation was a primary elevation for the building, and they wanted to keep that. As you can see over to the right, the design team did a really, really nice job of putting a modern entrance for us onto that building. We originally had that as a 3-story vestibule with stairs in it, and had gone back and forth with the Historic Society, and actually moved our stairwell into the building, and made this a nice vestibule as an entrance there. So just one of the small things that we had to work with in those historic boundaries to really keep the character of the building and meet the ultimate goals of the project. So from there, I'll hand it over to Julie.
Great. Thanks, Tony. Yes, this, as some of those earlier images that you saw, the building, Jerry Noble is quite a visionary. And when he saw that building and Pepper was initially considering purchasing the building, he reached out so that they knew there would need to be some structural work, but to understand the extent of it and make sure that they were aware of what they were getting into. So we did a preliminary assessment and review of the structure, and this is just some of the noted observable damage from that preliminary assessment to help work through with Jerry, so he would know what items needed to negotiate with the sale, and then also get their game plan for when they acquired the building. But I applaud him for having that vision initially and looking past the collapsed floors and missing wood and structure, and to see what it could become. Allison, thank you. So since the historic tax credits were pursued and we had to follow the SHPO guidelines, there's different structural engineering rules and regulations that go along with that. And primarily, you want to replace in kind. So you want to minimize what you take out. You want to preserve not only the aesthetic historical content of the building, but also the structural as well, especially any structural members that may be exposed or contribute to that aesthetic. So any wood members or things like that we could preserve, we would want to keep and strengthen if necessary, and minimize the need to bring in any new materials or do any unnecessary demolition. Go ahead. So to see these were some of the preliminary photos too, and we were dealing with all different types of building materials. There's load-bearing multi-wide masonry, there's some structural steel, and there's even the old clay tile walls. So there was a combination of different building materials and where they were, and this double-story space was intended to have floors, but they had rotted out and collapsed due to some extensive water damage. So you can see some of that demo was already taken care of for us when we got started. These, as the building, more construction and demolition and areas were made safe for us to access to complete the assessment, more water damage or areas of rot were identified. There's the photo in the upper right. It's kind of hard to tell, but that red little indication in the middle of that joist is the tip of a screwdriver. So if you can punch your screwdriver easily into your wood, it's usually lost its structural integrity. So some members we had to replace in full and could not sister or do a full replacement. But there was also, in addition to the water damage, I think there had been some fire damage previously as well. So those members also had to be evaluated and tried to preserve as much of the original integrity as we could. So here's some of the fixes. And it was also, COVID time where materials may have been hard to source and access. So we tried to give options for, and that's what the table in the lower left is. So if you had to replace, an old strong wood member with a newer wood member that may not be as efficient as the older wood, what types of wood in different sizes would be comparable for replacement, to be able to give Pepper options so that they could work within the material availability as well as budget. So we had to sister some existing joists, we had to replace in kind, and a multitude of different, replace almost the whole floors. That picture in the lower right is in the area where the floors had previously collapsed and were missing. I just can't stress enough with this project the collaboration and how great it was to work with this team, and everybody had the same goal in mind, to preserve this historic building and to do so in a responsible manner. So it was really exciting to be a part of it and to see it come to life. So our job was to make it stand and keep standing, and so far it's still standing.
Awesome. As Julie was just saying, this was just a great showcase in collaboration. And it sounds a little cliche to keep saying, oh, we all collaborated, but we really did. And credit to Jerry and the Pepper team for really pushing that from all angles. We had an opportunity with this project to do more of an integrated project delivery, as Pepper was not only the owner of the building, they were the construction manager for the building, and allowed us to really bring everybody to the table at the beginning. So it wasn't just the design team and Pepper and CMTA at the table, but it was actually the premier HVAC contractor and electrical contractor at the table during design to help us figure out how are we going to get to these goals. From the outlook, Pepper really defined, number one priority was we got to meet historic preservation. Second priority was they wanted to create a Class A office space for their employees. After that, it was, I'll say, bonus. If we could get high levels of performance and sustainability, that was great, but we had to keep those initial priorities in mind. So in order to do that, we had everybody at the table at the beginning to really front load what are those ultimate goals and how do we hold ourselves accountable to that. So to do that, we created an owner performance requirement document. So if you jump to the next one, there's kind of a snapshot of a piece of it, but this was really how we, from the get-go, tracked against, what's our target EUI, what's the benchmark, where are the areas that we can improve, either the envelope, the mechanical system, air infiltration. And this was a bit of a living document. So this is a snapshot from early on in the process where we set kind of lofty goals on what are we going to track towards. So you'll see like a really aggressive infiltration rate. While we didn't quite get down to a 0.15, we actually got to a 0.28 blower door test with multi-white brick and plaster. And we'll go into more in depth in that, but this really allowed us with the whole team to have this kind of overarching set of requirements that we were working towards. And then, as Tony said, we kind of backed into, hey, because of the decisions you're making, we think you're a prime candidate for LEED and WELL and net zero and X, Y, and Z. Again, here's that next one was more of the laundry list version of all the things that we were tracking in terms of performance goals. But and then we can go ahead and jump on to the next one. So how do we get there? From the get-go, when you have an existing building, there's a lot of things that are obviously already set and fixed for you in terms of, then Pepper choosing to move into Laughlin, that set a lot of things in terms of site configuration. The existing building set a lot of things in motion in terms of how it was already there. But part of the analysis was to really study and understand what are we working with. So the next slide, I think, has, again, kind of benchmarking, where are we, where do we want to be? And then the next one has a little bit more in depth of kind of initial climate analysis, again, with an existing building and an existing site. Some of these are fixed. If you are choosing a new site, if you're creating a new building from scratch, you have a little more flexibility in manipulating these. Again, wind, fixed building, the wind's kind of set. But what were fun things that came out of this was things like studying how do we maximize daylight. So you'll see from these diagrams, the building's a relatively compact square, and analyzing those existing 100-year-old windows and what's the daylight coming throughout the day, that actually informed how we ultimately programmed the building, putting the majority of the open office spaces and kind of regular day-to-day spots around the perimeter, and then moving collaboration zones more towards the center, like the boardroom that Tony mentioned earlier. That's kind of in the dead center of the building, but we utilized interior glass to get kind of, further light into the building, but also to really kind of locate function based off of what the existing building was giving us. Got another daylight analysis. Turn it over to Wyatt to talk about EUI benchmarking.
Yeah, thank you. While Tony is in a construction site, if you hear background noise from me, it is because there is a baby shower happening in our office right now. And by the sound of the laughter that I'm hearing in the background, it must be going okay. So try not to get too distracted. So yeah, as Brett said, there were a lot of things, right, that go into kind of front loading this project from a goal setting standpoint, developing the OPR. One of the really cool things about working with Pepper, it's kind of been mentioned, but it was these layered cake of goals, right? So that, first and foremost, the Class A office space, wanting to make a inviting, healthy, inspiring place for their employees to work, but they also wanted to lean into their mission statement. And so it wasn't a very prescriptive approach. It was all about setting, measurable targets and then figuring out how we could achieve those measurable targets. And so part of that process from an energy standpoint was really understanding, what was our target, our measurable target going to be from an energy performance standpoint in terms of EUI. And so we knew from the zero tool, AIA zero tool, that the baseline building based on 2003 CVEX data was an 85. To hit our goals for net zero on site, we knew we were going to have to be somewhere in that 17 to 30 EUI range, just to fit physically enough PV on the site to produce enough energy to be net zero. And then ultimately, our goal was to be net positive or at least net zero energy if possible. So some pretty ambitious goals. Um, we knew in order to get there, we were going to have to focus kind of on the biggest pieces of energy use in an office building, which is traditionally HVAC and then followed up by plug loads. So obviously being a historic renovation project, mass masonry, we knew that we were going to have our work cut out for us just to address reducing energy, reducing heating and cooling loads. And then on top of that, designing a very efficient system to meet those loads. So if you jump to the next slide, in order to achieve that load reduction strategy, I think Brett and I don't know how many iterations of wall treatment assembly options we worked through, but
I think it was at
um,
least 20.
yeah, too many, very, very many. But we've kind of found from our early analysis, just kind of doing a order of magnitude impact study, is that if you go back one slide, Allison, we knew that probably the most effective measure that we could take beyond insulating the building, beyond, adding insulation to the roof or walls was going to be air sealing. So we started to kind of layer up what our most impactful measures were going to be. And then from there started to permeate through options that address, insulation, air sealing, and various combinations of effectiveness of each. So if you jump to the next slide, again, we studied through a ton of options. Here are 7 of the 40 that I think that we looked at, but a lot of this was doing some pretty detailed therm analysis and moisture transfer analysis just to understand condensation risk and eventual longevity risk for this existing structure. It didn't have any existing insulation. Obviously, being historic preservation, we couldn't add anything to the exterior of the building because that would have impacted the existing cladding. We had some options to potentially fur, I think, up to 5 inches into the interior of the existing exterior wall, and then just finish with the same plaster finish. So we were really exploring options within a pretty thin margin. We had about 5 inches to work with. It was what can we do, what types of insulation, what types of furring, et cetera. And then understanding the temperature profiles of those walls and then what kind of risk that posed. So if you jump to the next slide, ultimately what we found comparing, our options of wall treatments to the impact of energy cost savings and overall EUI impact, as well as kind of managing the risk of adding any insulation and impacting the temperature profile of that wall. Where we landed working with Brett and Immersion and also Pepper and their quality control team is that kind of the best solution was to focus solely on reducing infiltration. And so we did not add any insulation to the exterior walls of this building. I think it worked out to be roughly a 5.5 R value. So it's just 4Y mass masonry brick. And then we refinished with interior plaster. And then credit to the Pepper team and everyone on the construction team that really did a great job of detailing that plaster and ensuring that we were able to reduce our infiltration rate significantly. So if you jump to the next slide, ultimately where we landed, we were able to go from an 85 EUI to a 30 EUI as far as our design building. And that's a 65% savings. Again, a lot of it had to do with air infiltration, but we also really pushed the needle in terms of efficiency in our HVAC system. We had a geothermal well field. We used a 6-pipe, heat pump chiller that's doing both heat recovery and highly efficient heating and cooling. We did a really interesting thing on the outside air and ventilation strategy of this building that actually scrubs the air, so it reduces how much air we have to bring into the building from a ventilation standpoint, which saves a lot of energy from a conditioning standpoint, but also really helped with indoor air quality. If you noticed on the bird's eye view from the satellite imagery in the beginning, this building's located right between north and southbound 75. And so you get a lot of ozone, a lot of PM 2.5, PM1, PM10, just in the ambient air around the building. And so by reducing how much outside air is coming in, we were actually able to improve indoor air well above outdoor air standards. Did a lot with energy efficient lighting, reduced plug loads, made sure they couldn't have any bevy machines despite how much they begged. No, just inside joke there that bevy machines that we found were going to be roughly, I think, 1 or 2 EUI for this building. And so very quickly, we were able to say no carbonated water on site. And then domestic hot water, we also just used really low flow fixtures and then used really efficient domestic hot water heating. And then on top of that, obviously we wanted to be net zero. So between the the rooftop arrays and then the addition of a parking canopy, we're able to, I forget what the actual KW rating of this array is, but able to offset 115% of annual energy use. So the building is net zero, actually net positive, and that is now officially verified. So while we predicted a 30 EUI, I think the first year we operated at a 29. I believe the second year it operated at a 28. And the first year there were some commissioning issues getting solar online, but in year 2, the building did produce, once all of the solar was online, the building did produce more solar energy than it consumed from the grid. And so it did become a LEED certified net zero building. So then beyond just doing the project, some things that we've continued to learn as we've, studied this building, understood its impacts, and found opportunities for us to continue to improve going forward. As we started to look into the embodied carbon of not only the structure and enclosure of the building, but also the MEP systems. And so this is a good reference material that I won't dive super deep into, but it does come from CLF. It's a Washington State carbon emissions estimation study that they published a couple months back, I believe. But it shows the potential order of magnitude of MEP systems on both operational and embodied carbon. And so that really the graph on the right is the one to look at, but it shows the low and high end estimate. If you look at MEP's, whole life carbon impacts on a building, including refrigerant, operational emissions, and embodied carbon, MEP can be roughly 75% to 64% of a whole building's whole life cycle emissions profile. So we wanted to understand what does that look like in terms of Pepper. And so we did an LCA on the MEP systems. And what we did find is that it does have a significantly higher embodied carbon or emissions intensity or embodied carbon intensity than typical industry estimates. So, typically you see somewhere 250 to 300. We are in the 500s. And you can go to the next slide. And so we really wanted to drill in and understand, what drove that and what decisions could we have made to be better. Kind of an interesting takeaway that we were very curious about was how impactful is geothermal in terms of emissions, because this does have 16 300-foot geothermal wells. What we found is it's actually very minimal. There's no propylene glycol in the system, so there's very little refrigerant impact there. And because it's not a cement-based mortar, it's a bentonite-based mortar, it's pretty low. What the biggest impact was the solar PV array. And now what's significant about this is that a lot of that actually comes from the structure of the carport canopy, more so than the rooftop array. So you have the panels, but you also have the structural steel and concrete and everything that goes into supporting those carport arrays. And so when you add all of that up, you can see how MEP embodied carbon for this project compared to both operational emissions in green, as well as the structure and enclosure that Allison's going to talk about here in a second. And again, this is an adaptive reuse project. There is very little structure that we added, relative to the whole building. There's very little enclosure that was added relative to the whole building. So that drives the emissions intensity way down. But MEP, again, is almost 6 times that value. It's just a good opportunity for us to understand, how we can potentially improve this in the future. So it begs the question, should we have put the solar on? Did it save enough operational emissions, being net zero energy, to justify the embodied carbon? Well, the answer is yes. If you jump to the next slide, it basically saved 5 times the amount of operational carbon that it added in embodied carbon when we look over the building's life cycle. And so I think it's fair to say, especially in this region of Ohio, that solar makes sense, but it's a good opportunity for us to figure out ways to reduce those MEP embodied carbon impacts going forward. And I think overall, if you factor in whole life carbon, and maybe Allison will get to this, I think we achieved basically a 95% reduction from a new construction project. So still very significant whole life carbon reduction impacts for this building. With that, I will hand it over to Allison.
Awesome. Thank you, Wyatt. So building more on the whole building embodied carbon life cycle assessment, we'll go through some of the details after this, but just some baseline of what material was retained. on the historic building. So after 20 years of vacancy, we were able to restore over 25% of the brick and 100% of the detail work. And then half the windows were restored locally. So saving those further emissions from transportation to a farther away site was also saved here. And then some of the historic vault doors, which we will go through later on in some final project photos. So we used the one-click LCA software and went through life cycle stages A1 through 4, which included construction material extraction all the way to transport to the job site. B4 and 5, which includes replacement and repair of materials throughout the building's life cycle. And then C2 through C4, which is the end of life stage, waste and processing of materials once the building reaches its end of life. So the scope included the entire shell of the building, so the superstructure and enclosure, and then the LCA was completed after occupancy of the building. So some more details, the benchmark, which you can see on the left here, the building was compared to a baseline new construction ground up office building. And then based on the amount of the building that was retained and lower embodied carbon materials suggestions that were included in the project, we achieved a 64% reduction from what would have been a new office building. You can see on the right here on this graph, the largest reduction was on horizontal structures, so floor deck and beams that were able to be retained from the structure. Something else that helped with reducing some material embodied carbon on this right side was the requirement to retain a lot of the material on the exterior envelope of the building to keep up with historical guidelines. So a lot of the exterior brick and other detail work on the facade. So yeah, we were able to achieve the historic tax credits with that requirement, and then it helped us with our embodied carbon savings here. So you can also
Allison, if I could jump in on that one. It was just neat to really take the deep dive to understand that even though we're saving essentially the existing brick building, there's still an embodied carbon impact to preserve that. So as Allison was saying, we end up tuck pointing about 100% of the detailed brickwork, for at least the first wife. So that amount of mortar, tuck pointing and replacement still plays a role in preserving the brick. So it was just really fun to see how, accounting for that, there's still a significant reduction, but there's always that push and pull of, well, we're still having to do something to preserve it.
Awesome, thank you. And so yeah, I think that's left on the slide. Just majority of this impact that was reduced on this left graph again was in the A stages, and that's all material related. So I'm going through some lessons learned from our LCA. So just reiterating the importance of having a collaborative team. I think everybody's brought that up at some point so far, but there's so many challenges that came up with adaptive reuse in historic buildings. So it's important to have the right team that was able to work together and achieve all of our goals with LEED, gold, WELL gold, LEED zero energy, and then also reducing operational carbon with all of those certifications. Our first point here was why it was able to do a deep dive with the MEP LCA, and that sort of came on with this project and helped bring on that opportunity. And then Pepper was able to explore a couple different LCA modeling softwares and really learn from those and figure out what was going to work for us moving forward. And then starting to build our LCA database internally with Pepper, kind of spearheaded with this project as well. And this was a great case study to use for that. So lastly, we'll go back to Brett to go over some of the outcomes and achievements of the project.
Awesome. So we'll do a quick, just kind of flip through some before and after photos. And then there's kind of a slide at the end with some high level stats. But as Allison flips through these, I think as an industry, when you hear historic preservation, you hear sustainability, you immediately think they're in conflict. That you need to rip out all those single pane windows in order to make an energy efficient building. and this project really debunked a lot of that. And there's a sweet spot of saving what you can and improving it and still getting high levels of performance and sustainability. And then everybody wins. You've achieved historic preservation with single pane windows. You've, you know, it feels so weird as an architect to say don't insulate your walls. Like that just fundamentally feels wrong. But you can make the equation work. So this was just a great opportunity to really get everything working towards, you know, one kind of overarching goal.
These are those vault
fun
doors.
vaults.
Yeah.
The picture on the left there on that last one was kind of the before. You saw some of the photos previously in the presentation of seeing like the steel coming back. This was the before scenario before all the demolition got removed. And again, kind of quick highlights of you know where are those performance metrics today. So again, air infiltration down at 0.278 at 75 pascals. Wyatt mentioned the Invarid system that is producing cleaner indoor air than the outdoor air coming in. Again, this overarching kind of solar offset to bring the building to zero. The new entrance is highlighted there. That was a move really for universal design and accessibility. Tony had mentioned the existing entrance kind of on the far left of this image off the street was actually not really accessible. You had to go up several steps to get to the door, and then you had to go up several more steps in the building. There was no easy way to make that ADA friendly. So ultimately pivoted to the addition there on the south from the parking lot. And yeah, so all said and done, we achieved the state historic tax credits, which for the state of Ohio, the Ohio tax credits is actually a competition twice a year. So Pepper won their round of the competition for the state tax credits. And since then, officially certified LEED Gold, officially certified WELL Gold, and with the solar offset, officially certified LEED Zero. So you can do all of the things.
Yeah, that is it. Thank you all for joining today.
I'll tell you what, if you could hear me clapping, I would. This is such a cool project. Thank you guys for sharing with us today, and I'll open it up for questions. But I guess my first question, and Tony, probably for you, was there a comparison or a decision made to pick this over a new build, or was it stay where you were or move here?
We were going to move.
Yeah.
We had a few sites that we were looking at, mostly ground up buildings. But as a few have mentioned, Jerry really saw what this building could be, I think, before a lot of us did.
And I guess a follow-up for Wyatt, when you were doing your LCA for the MEP and especially the embodied carbon side, did you struggle to get EPDs from suppliers, or were they pretty forthcoming with that information?
Yeah, it's a great question. So, there are very limited, well, there are EPDs for certain projects across MEP that you can find, but very few are product specific. And so getting manufacturer data in the US, in particular for MEP equipment, is very difficult still. So we are actually participating as part of the MEP 2040 pilot study, is what this project LCA on the MEP side kind of took place as part of. So a lot of the data is still proxy data. So there's a lot of error margin still in some of the specifics that's kind of accounted for in the background data of the LCA. But I would say I was pleasantly surprised to find that we were able to find at least some sort of proxy or adjacent piece of equipment for roughly everything incorporated into the LCA. But certainly an area for improvement for the MEP industry is to continue to solicit EPDs from manufacturers and hopefully get more and more on board with producing those and then making them readily available so that we have more product specific information when we're doing this exercise.
And this is the first project I've seen that has done that deep dive into MEP. So I actually have a ton of questions, but was it more the equipment itself, or was it a lot of the routing of the ducts and conduit and wire and everything else that comes with MEP?
Yeah. So there are very few. I think this is one of 20 projects that were in that pilot study. I mean, there's been, more than that that have been done, but all with varying degrees of scope included and different processes for conducting the LCA. We're still kind of waiting on the MEP LCA standard guidelines, but um, in this particular case, the distribution is mostly hydronic, so there's not a ton of duct work throughout the building. Part of that was because we had to minimize what you saw from a historic preservation standpoint. And so there's some ventilation duct work, but it's a lot of hydronic piping to fan coil units. Um, and so the largest portion was in the MEP equipment in this particular project, and less so in the distribution. But they weren't too far off. They're close to parity with each other. But in other projects that we have done, it sometimes flips, just depending on what, if you have big air handlers, but a lot of ductwork throughout the building, your equipment might be a smaller piece of the pie, and then distribution, ducts, pipes, et cetera, become a bigger portion in MEP. So kind of depends on the building. This one's pretty compact as well, and so that helped with minimizing distribution, but still the fan coils, the chiller, all the pumps, etc. That's where most of the MEP embodied carbon lived outside of the solar.
I have a question. And I actually have heard about I was at a conference and I've heard you guys speak about this project before. I love it, so I want to hear about it again. Um, what do you feel like has changed after this project, in terms of, working with clients, working with owners, having newer projects now where you feel like from these lessons learned, you're trying to integrate or, have change the process or change, things with other projects or other owners, or just like those conversations that you're like, oh, this is such a great example. How do we do more of that with other projects? Do you feel like there's things like that where you're finding yourself referencing back and then like trying to pull through to new projects?
If I could jump in first, I would say absolutely. One thing I think is really powerful about this is when we talk about any one part or piece, it's part of a whole. So when we talk about the mechanical system and the decision to go geo, that wasn't necessarily just for efficiency. That was also from a square footage standpoint and from a SHPO standpoint for historic of, what's the way we can maximize the system while minimizing how much footprint we have in the building dedicated to mechanical versus we can't exactly put an air handler, a traditional air handler on top of the roof or a chiller on top of the roof and align with historic guidelines. So a lot of times I think when people talk about geo, they get nervous about that, oh, it's just my first cost. My first cost is higher. But really you need to think about what are you gaining from it just in terms of your square footage or how much you're giving, square footage within the building to your mechanical systems versus leveraging what you can put in the ground. So seeing that on kind of every part and piece of this project has really helped kind of pull that first cost mindset up to what's your total package looking like, and what is your end game, and how are you shifting dollars and square footage and systems within that to maximize what your overall return is going to be.
Tony and Allison, have you guys noticed any difference in recruiting, bringing especially younger people to this office compared to where you were before?
It definitely helps. I think our industry right now is pretty difficult to hire in, regardless, but having the amenities in place, it certainly is a point to tour people through the project, speak about what we can do and show them it in person. On the previous question, does it make us change how we do anything? It's certainly with clients, it certainly has changed our approach. That there's been a lot of things that I think we've taken for granted that owners go through on a day-to-day basis and decisions that they need to make that we necessarily don't always need to make those decisions. And so, Brett had mentioned kind of looking at the whole thing. It's really put us in a position to manage clients on some sides and help point out areas that maybe they need to make a decision to not impact the project or just be aware of what they're going through on their own journey. So yeah, hopefully that answered your questions.
Yeah, I think the well certification also makes a big impact because it just kind of goes to show how the building truly was designed for the occupants in mind, on top of everything else. It's focused on creating a better and healthier work environment. So it just makes it more, uh, I don't know, more inviting, and people are definitely more interested in that. And just the fact that you can see the solar panels over the parking on display too, it's just cool to see as you pull up to the office as well.
I'll give about 10 more seconds for any other questions. And if there's no more, thank you all for sharing this project. Super cool. I'm excited to revisit it and share it with other people because I think this is a story that needs to be told more, especially here in Ohio, in the Midwest. So, thank you guys for sharing what you guys learned and the experience you guys had. And hopefully, we get to hear more stories like this soon. Thank
Thanks,
you
everybody.
all.
Yeah.
Thank you.
Thank you.
Thank you.
Thank you.